Little bit of scatter plots today. I know you don't have this definition of scatter plot on your worksheet. That's okay, but it just shows the relationship between two quantitative variables measured on the same individuals. So like this is about the weight of probably some diamonds in carats, you know, as a quantitative variable, and the price of that diamond in thousands of dollars. So they're just comparing two quantitative variables. One is on the horizontal x-axis, and the other one's on the y-axis in that situation. But each individual data set appears as a point on the graph. So what we're going to do today is describe them. And the way we describe a scatter plot is four things: the direction of it, the form, the strength, and if there's any outliers. So the direction, it can either be positive or negative. Let's just kind of dive in on this guy, just with your logical sense of not even really being instructed. Here's the dot plot, right? What do you think? Positive or negative direction? Yeah, isn't that like, as you read from left to right, aren't those dots like increasing, right? So we can do that. The direction of this guy is positive. What do you think about the form? You got basically two choices for this class right here: linear or non-linear. What does linear mean to you? Looks like a line, and non-linear would be curved. Like we have done parabolas so far in this class. You know, there's other types of like non-linear graphs, but what do you feel about this guy? Linear or non-linear? I guess we've also done exponential growth. You know, isn't that kind of like an exponential growth graph? So we would call this guy like, I'm cool with either putting curved or nonlinear. It would probably be more mathematically appropriate to put nonlinear. And then what we'll do today is figure out how to describe the strength of it. We're just kind of dipping our toes in the water. Then I have a game that we're going to play in class. If you're on video land, you won't be able to play this game because it's just too long and too much fun. And there are prizes available for this game as well, so must be present to win. But the strength of this guy is, how well do you think that these dots fit this curve in this case? Because it's nonlinear. Like, do you feel that is pretty strong, pretty moderate, or pretty weak? It's only our first example. What do you think? Are those dots really close to the pink thing that I have highlighted? What do you think? I feel this is very strong. It does get weaker as it goes farther out. You agree with that? Down here, isn't it very, very strong, nice and fitting to that curve? And then they start to spread out. But this is, without knowing any data, pretty strong, right? Pretty strong. You don't have to put the dots don't vary much from the curve. You can just put strength, strong. Strength, strong. And there are mathematical ways to figure out outliers. Right now they're just like saying, do you feel there are any outliers? That would be dots that are like way out of place. I'll put one for you. Like this red dot right here. Beep. Isn't he way offline compared to that curve, you know, in that situation? Because that red dot should be roughly around here if it was fitting the pattern right, you know. So what do you think? Do you feel there's any outliers? I would say no apparent outliers on this one. That's just roughly describing that scatter plot. What's the direction? Positive or negative. What's the form? Linear or nonlinear. What's the strength? We'll get better at that as we go along, right? And then outliers. We're just guessing again. It looks like this could be a possible outlier. So let's try it again. First of all, what is the direction of these dots? More positive or more negative? Yeah, you can see it's kind of going down from left to right. And I can't even like do this. Like I was going to put a blue curvy thing, you know. But it kind of, to me, the form kind of takes precedent before like the direction. Like what do you think, linear or nonlinear? Does the red line look better or the blue curve? Let me get rid of this again. Sorry, I hit the wrong button. What do you think, linear or nonlinear? I would say more of a linear pattern. So the direction was definitely negative, because this is what it would be like if it was positive. There's no way that those dots are fitting that pattern. You know, it's just like, eh. So it's negative. The form is linear. And now for the fun part. What would be the strength? Well, first of all, I got a purple line here. I got a green line here. I got a red line here. You know, I could put a blue line right here. We'll learn later this chapter where the line of best fit is for these graphs, right? But first of all, who are some bad ones? Like there's a linear. Which ones are like not the best in this? the blue one and the purple one because we kind of don't have the dots in the right spot, right? So like if I get rid of the blue one and the purple one, you see like the red one and the green one are pretty darn close to where like a true line of best fit would be. But are they really stinking close to that? Really, really far away from it? Or kind of medium-ish? What do you think? What would you say? Medium. So what do you think that means? Strong, moderate, or weak, the strength of this guy? That would be moderate, right? That would be moderate because there's no perfect one line that's just going to fit. You know what I mean? It's like this guy could work. Sorry, that's not a line maker. This line could work, and so could this one. You know, it's like, how do we know which one's better? It's just like too spread out. What do you think about outliers, though? Do you feel there's any apparent outliers? Or knowing that it's a moderate pattern, do you feel everyone's still pretty darn close to where we're at? Now, I also feel that way. There's no apparent outliers. So that's just a basic intro into describing a scatter plot. Then here's some real data. I totally trust that you guys would know how to put this into the applet, right? You know, so I have already done it. What we don't put into the applet is the names of these candies right here. So here's all these candies. We don't need to put those in. I have like the spreadsheet. We would do like one quantitative variable, multiple groups. One group would be sugar, and the other one would be calories, right? So it's just like, hey, what's the relationship between all these candies, the sugar content that they have, and the number of calories? So I made the scatter plot for it. I put sugar on the x-axis because it came first. I put calories on the y-axis because it came second. In all seriousness, it doesn't matter which one's on which, right? You know, because they kind of just don't relate to each other that well. But let's talk about the direction. What do you think? Positive or negative? Positive. And now it's time to really dive into what that means. As the sugar increases in your candy, what happens to the calories? It would also increase. Are you with me on that? That's what a positive relationship means. You know, like whatever's on your x-axis, because since we read that from left to right, as it gets bigger, doesn't this also get bigger? If it was negative, it would do the reverse. As sugar gets bigger, calories get less, but that is not happening. What do you think the form is? Linear or non-linear? Is right. You know what I mean? This guy's messing things up. Would you agree with that? Guess why that guy's messing things up? He's probably an outlier. So for one, if you think there's an outlier, let's just pretend for a second that it wasn't there. You know, just kind of cover it up. What would you think now? Linear or non-linear? Looks pretty linear compared to like curved, right? You know, so I'm going to get rid of that guy. Let's show him back. I'm going to say that this guy is linear. So like kind of ignoring that outlier for a second, isn't this decent? You know, like that line is decent, but it's not like this one's worse. You know what I mean? It's like that could be close. It could also be like this one right here. But this outlier really kind of messes things up with that one. So what do you think? Strong, moderate, or weak? I would call it, we'll definitely see some weak ones here in a little bit. You know, I would still call this moderate. You know, there is a general pattern. When you see a weak one, for sure, you'll be like, okay, now I see why it's weak, right? So I would call this moderate. And then we said there's definitely an outlier. You know, so who is it? Which one in the chart is the outlier? It's the one that's got roughly, you know, like 80-ish calories, 80-ish grams of sugar, but almost 800 calories. Which one is that? Peanut M&Ms, right? You know, isn't that probably our outlier in that case? So I'd say one possible peanut M&Ms. And I think we're doing awesome with this. We still barely know anything about describing a scatter plot. We've just done 3 of them so far, but this is real data, right? You know, based off of the candy wrappers and the nutrition things and all of that stuff. This is how much sugar's in here. This is how many calories it is, you know. So, but the peanut M&Ms probably have some more calories in some fat. You know what I mean? Like peanut has all that oil in it and everything, so there's just something in there besides sugar causing all the calories. You feel pretty decent with describing a scatter plot, right? So that's the end of that part of the lesson. Now, let me switch to do a different lesson, and we get to play a little game after just studying this. Here is a bunch of different scatter plots, and there is some math on the background called the correlation. For example, like how well does sugar in a candy correlate with calories? What this correlation coefficient is called is R, and I just want you and a neighbor to talk. What do you notice about what the graph looks like compared to the R value that you see underneath that graph? Discuss a few things that you notice. There's a couple things that should stand out at you. I think the first one you probably noticed is some of them are positive, some of them are negative, right? Why are the positive ones positive and the negative ones are negative? Because of the, starts with a D, the direction of this. Like, why is this a positive 0.5? Because wouldn't you describe that as a positive direction in that case? And why is this one a negative 0.7? Is because those dots are going down from left to right. So the positive and negative means literally that. You know, this is a positive direction, this is a negative direction. Then what else did you notice? Numbers are getting closer to 1. Right, you know, because if they're closer to 1, what do you think about the strength of these graphs? Stronger. This one is not even close to 1. Not even close to 1, but it's like really, really strong. Why is it not close to 1? It's really close to which number instead? -1, right? So the strength is about being close to 1 or -1. Are you with me on that? The negative means you're strong going down. Right? And the positive means you're strong going up in that case. So which one's the weakest? Let me just call them B, C, D, E, and F. Which one of those do you feel is the weakest graph up there? A has no correlation to it whatsoever. You cannot tell if it is a positive graph or a negative graph. Are you with me on that? Like this line right here, is just as good as that line right there of describing that. There is no correlation between whatever is on the x-axis, call it calories, and sugar or something. You know, it's like they have nothing to do with each other. So if we are in class, we get to play a little game today. If you're not in class, no big deal, but you missed out on something fun. All right. So we got done playing our game, and it's about correlation. Correlation is your R value, my friend. So we're down in the bottom of that worksheet, that little bitty tiny chart. R's got to be between -1 and +1, and it measures the strength and direction, which, if you were in class, we played this game, we're pretty good at. We did the strength and direction game, and negative means it's going down from left to right, and positive means it's going up. So if R is close to 1 or -1, the model is considered, what would you say? If R is close to 1, the model is strong, right? Strong. That could also be -1. The closer it is to 1, the stronger the connection. The correlation, I should say. What if it's close to 0? The model is very weak. Very weak. And here is a tough one to read, right? But what if it said R is exactly 1, which can happen, or R is exactly -1? What would that mean about the correlation? It is, even besides very, very strong, starts with a P, it is perfect, right? It is a perfect fit, right? It is a perfect fit. If you get correlation of exactly 1 or -1, that data is 100% perfectly correlated. And if it is 0, there is no relationship between the variables. There is no linear relationship between the two variables. And then let's see if we can fill in this blank. The relationship is blank. If the relationship is blank, then R is less than 0. If the relationship is negative, right? And if the relationship is positive. So now that we learn a little bit more about it, here's how we can define our strength a little bit better. Like anything that is 0.8 or better for a correlation coefficient, we're calling that strong. Sorry, that's not a highlighter. But your correlation coefficient, which the applet will figure out for us, if it's 0.8 or larger, you're strong. If it is less than 0.5, you are weak. And in between there, that is moderate, right? So what would a 0.637 be? Strong, moderate, or weak? moderate. 0.333, weak. 0.499, weak. Cool? So, all right. So here's some data, and they measured this. Hey, does where you sit in class affect your test score? Some people feel yes. Most people would probably say no. Like if I had you take a test in here, does it truly matter where you sit? Some people hate that change. It's like I've always sat in this seat. I can't concentrate. Everything's off. My nerves have gotten to me, and it's just this. But here's the data, right? So there's 7 rows in this class. They sit in row 1, 2, 3, 4, 5, 6, or 7, and then they measured what grade you got. Here's a scatter plot. Describe it. What is the form, positive or negative? How hard is it to tell? Very hard to tell, which means that this relationship is weak. Are you with me on that? Very, very weak. So because the relationship between these, here's what the book says. They're calling it a little more negative than they are positive. I think that is still up for grabs, right? So because the relationship between raw score and this, sorry, I didn't have that filled out, is negative, use a pen, negative, then could you fill in that blank right there? R is what than 0? Either put a greater than or a less than. What would you put on that bad boy? R is less than 0. Also, R is closer to what number than what number. We're putting like zeros and ones in there. R is going to be closer to 0 than 1 because the relationship is strong, moderate, or weak. Weak, right? This is weak. And if we had to guess, I would put this at the like 0.083 range. You know, it would actually be negative 0.083 because they say it's negative. But isn't it very, very close to 0? So what do you think about this? According to this data, does it matter where you sit compared to your grade on a test? There is no correlation between that. Almost no correlation. Let's put it that way. It really doesn't matter in that case. That's what that is all about. Right? So one more of those. This is about somebody's 40-yard dash time. Right? Somebody's 40-yard dash time. And then they did long jump. Right? They did long jump. So first let's describe it out loud. Positive or negative? Negative. So let's see what that means. As their 40-yard dash time does what? Increases, doesn't that mean they're slower, right? You know, so the slower the runner, what about their long jump distance? Did they jump farther or did they jump smaller? Smaller. So like the more your 40-yard dash increases, this data shows that your long jump also goes down, right? And check it out. Here's the correlation. Boop, negative 0.838. So what do you think? Is that strong or weak? That is very strong, right? Because isn't it over 0.8? I know it's negative 0.8, but you just think of it as positive. So that is strong, and it is also negative in that case. So what do you think? Is there a correlation between somebody's 40-yard dash time and how far they could long jump? According to these people, right? It doesn't mean in general, right? The people that they studied, definitely yes, right? There is a strong correlation between those. And then things to watch out for. A correlation close to 1 or negative 1 doesn't mean it's linear. Would you believe that this was one we did earlier? Isn't that a curved pattern, right? So you could find that maybe an exponential growth formula fit that, and it could be very close to 1 or negative 1 based on positive or negative. So don't think that everything has to be like linear in this case. This R value is 0.93, which is very strong. Are you with me on that? But it matches like an exponential growth curve, which we'll do in lesson 10.8 kind of stuff. And then the last thing of the day is just realize this. Correlation does not imply causation. Are you cool with the causation means something that causes it, you know? So here is some real data. This is real data is how much chocolate every resident in a country consumed, kilograms per year. How much chocolate they ate in all these different countries, right? Compared to how many Nobel laureates there were for every 10 million people. What do you think about that? Linear or nonlinear? I see you know. let's just go with linear just for the sake of like simplicity. Is that okay? It's like it's positive, right? Here's the correlation. Interesting, strong, moderate, or weak. We got to go with the definition now. To be strong, you have to be what or bigger? 0.8. That's so stinking close, right? Isn't that like the strongest moderate we're probably going to get? But it is still moderate. Are you with me on that? So it is moderate. So we will say that that is moderate and positive. And some people even put in there, it's like, strongly moderate. You know, it's because it's like that's a whole lot more stronger than, say, a 0.555, which is like one of the weakest moderates you could be. You know what I'm saying? So it's kind of moderate and positive. And here's my question. Does that mean if we start eating more chocolate, we are more likely to win a Nobel Peace Prize or whatever Nobel Prize? Yes or no? Is there correlation? Yes or no? Yes. Does chocolate cause you to, like, totally win a Nobel? Like, get the silliness out. Let's be honest. Does just eating chocolate cause you to be a Nobel laureate? No. That's why they're saying just because things are correlated, it doesn't mean that they are going to cause it, right? It is just a graph of data that so happened to match up to a R value of 0.83. So here's what we'll say. Sorry, hit the wrong button. Probably not. You can't rule it out, you know. But it is probably not, bro. Correlation does not imply causation. Correlation does not imply causation. And then one of the greatest things that I learned in my psychology class back in the day when I was in college, I don't know if it has anything to do with this, but I do like to talk about it. Did you know that they told us that there was a study that says as the number of, as ice cream consumption increased, so did the amount of drownings. Does that mean that eating ice cream causes people to drown? Or is there a hidden variable in there somewhere? As ice cream consumption increases, so did the amount of drownings. Can you find a hidden variable in there? So we're a little confused. No big deal. Here's what I'll ask you. When would you more likely eat ice cream? Let me just go with summer, spring, winter, or fall. When are you more likely to go swimming? Why did ice cream consumption increase and drownings also increase? Because it was the summertime and more people are swimming, right? So in Kansas, in December especially, I don't know too many people swimming. They have some indoor pools, right? But going outside, we're probably not doing that in December, right? So there is a hidden variable in there that, hey, ice cream consumption totally went up. So did drownings. Does eating ice cream cause you to drown? No, it does not, right? There is hidden variables. It can, right? You know, it can, but it is not likely. Let's do some homework.